Okay, now let's see this problem here. It's kind of tricky, a lot of ways on solving integration problems, so take a moment to pause the video and try to find the okay, I think we have a place to start with. We can let's change a variable u to be equal to x squared. Want here to be u squared. Okay, let's see. Okay, u equals to x squared. Let's differentiate this one. This one differentiated, it's du. This one, it is 2x dx. Then what do? Let's here we have x dx. What is x dx? So here I can say x dx equals to du over 2. Here I divided by 2, this 2 came here. So instead of writing x dx, I'm changing the variable now to u's. X dx is du over 2, so I can just write du here over 2, then under root 1 minus x power 4, but u equals to x squared, so 1 minus u squared, because if you square it here, it will be x power 4. I think you understand here. So now let's get here it's 1 over 2 gets out of these brackets, these integrals. It is du over under root of 1 minus u squared. Okay, forgive my bending and writing, I hope, but you understand. Okay, now here simple, now we can solve it easily. We have simplified it. Here we know we let u to be equal to sine, let's say p. So du, if we differentiate it, will be equals to cos p dp. Okay, now so here I write 1 over 2. I go back to this integral of du. Instead of du, I write cos p dp, over, it is 1 minus u squared, but u is sine p, so it is sine squared p. I think I'm clear here. Okay, one in our trig identity is 1 minus sine squared p under root this equals to cos p, so it is 1 over 2 brackets cos p dp over cos p. So this and this one, so it is 1 over 2 integral of dp, which is 1 over 2 p. Okay, but what is p? P is sine inverse of u, so this is 1 over 2 sine inverse of u. But okay, what is u? We want to express it in the terms of the variable which are given in the question. So u equals to x squared. Here you can see it, u equals to x squared. So the final answer here, it is 1 over 2 sine inverse of x squared, but don't forget plus